Hi, this is the video for lesson 2.2.1 from the review preview from CPM Algebra 2. Problem 2-107 says use the point HK to help you write a possible equation for each graph shown. So I see here that this is quadratic. We have a vertex, so we'll probably want to use vertex form, y equals a times x minus h squared plus k. So because of its shape, I'm going to make the assumption that a is 1. That's something you could look at in Desmos too, or you could even solve to be more accurate, which we are going to do in part C. But we'll just say it's 1, and then x minus 2 squared plus 3. Part B is cubic. I can see my vertex of 2, 3. So I think it's going to be something like, y equals x minus 2 cubed plus 3. Now for part C, we do have even more information than just the vertex like in part A. So I'll show you how we could be really specific, because I can see that it is facing concave down, so that's going to tell me that A is negative, and it's a little bit thinner than the one in part A, so I don't think that it's going to be a negative 1 either. So right away I know for sure that it's going to look something like this. 0 goes here. This is a -6, so that'll become positive. And I know this point -7, -2. So I'm going to plug that in for x and y, so I can really figure out what a is going to be here. So that'll be -1 squared plus 0. This becomes 1a. And I guess we can get rid of the 0 here at this point. I don't need to keep writing that. So if I even divide by 1 on both sides, -2 is equal to a. All right. So I'll make a better 2 here for everybody. So let me make this a little smaller. And then we can go ahead and write our final equation now that we know a. So y equals -2 times x plus 6 squared. For part 2-108, it says find the domain and range. So we need to find the domain and range for A, B, and C. Okay, so when I look at all of these, I don't necessarily see any limitations with my x-axis or my domain, right? These have their arrows and they could keep going and going. There's not something that like the domain can't be. So for all of these, we're actually going to write all real numbers. Okay, and then for the range, for the first one here, I see that on our y value, for our y values, we're either at 3 or above. So y is greater than or equal to 3. Here, I don't really see any restrictions. It looks like it's just going to keep going, so that's also all real numbers. And for the range here, I see we're either at 0 or below. So y is less than or equal to 0. Okay, for part 2-109, it says for each of the following equations, describe how D transforms the parent graph. So what you can do is actually just go to Desmos and look at each one of those. So let's do that. 5y equals dx cubed is what that is, or is that squared? Cubed, yep. I can add a slider and play around with it. So what I see this does is it affects like how it transforms, has that transformation is either is it compressing or is it stretching. Okay, so that would be for the first one. Y equals x squared minus d. Let's add the slider. So this shows me that it's either making it go up or down. Part C. I see that this is going left to right, so it's shifting it that way. or y equals p. I see this is shifting up or down. Okay, so that's how you'd find something like that out if you were just working on this on your own. I will go ahead and write that down. So this one compresses or stretches. This one we said shifts up or down. And that was also for this one as well, shifting up or down. And this one was shifts left or right. Okay. 2-118 says the graph of y equals x squared is shown as a dashed curve. Estimate the equations of the other two parabolas. So this one is the parent function. So what has happened to change them? Okay, so we can look at the first one. I know that a is positive and it is a little bit thinner. So I could estimate that this one, instead of being 1, is a would maybe be 2. Right, so we could say 2. And then I have our h and k here, so this would be minus 5 squared plus 2. For the other one, when we're thinking about a, we can see that it is flipped upside down, so it's going to be negative, and it's much wider than the original. And it's much wider compared to this one as well. So we know it's going to be negative. We could say like negative 1/2, maybe negative 1. Maybe we'll go with negative 1/2. And then this stays the same. Okay. 2-119 says find the x-intercepts and the vertex of y equals x squared plus 2x minus 80, then sketch it. All right, so how about, we could start with factoring. So we have y equals x squared plus 2x minus 80. So because a is equal to 1, we don't really have to use the diamond method. We could just split them up. And for these two numbers, we think what multiplies to be negative 80 but adds or subtracts to be 2. So if we think about factors of 80, one factor that sticks out to me are 10 and 8. If I had a plus 10 minus 8, 10 times negative 8 is negative 80, and 10 minus 8 is 2. Awesome. So we can find our x-intercepts. Okay, so we have our two x-intercepts here. We could plot those, negative 10, 0, and 8, 0. Okay. Now we probably want to start finding our vertex, axis of symmetry, that stuff, so we can use our negative b over 2a. That would give us our x value. So it'd be negative 2 over 2 times 1. So that is negative 1. So that is our h and axis of symmetry. So I'm going to put a dotted line there for now. Okay. And then we can plug that back into the equation. So that is equal to negative 81. So our vertex then would be negative 1, negative 81. Okay, and we did talk about too y-intercept. Y-intercept in standard form is always c. So we can go ahead and put a point at negative 80. Okay, so I think we have enough to go ahead and make a sketch. It's not a very good line. All right, I think that was all the pieces it asked for. Yeah, so we got it. And then the last one is negative 578, determine the sequence defined by t of n equals negative 5n plus 7, justify. So to see if this is a sequence, we can actually just plug it in for t of n and see if we get a whole number as our answer for what term it would be. So that is actually 117 equals n. So this would be yes when n equals 117. Okay, that's the end for this video. Thanks for watching.